Hi, today we're going to learn about ratios. The objective is to understand ratios as comparisons, and this is page 29. All right, so first of all, what is a ratio? It is a multiplicative, meaning multiply, or technically you could divide, comparison of two quantities with the same units. Okay, so they're comparing the same types of things like apples and bananas, they're both fruit. Okay, roses and daisies, both flowers. Okay, so here are three types. You can have a ratio that compares a part to a total, a whole or total to a part, or a part to a part. So it's kind of similar to a fraction, where a fraction is part over whole, but a ratio you can actually do it vice versa, the whole to the part, or comparing two parts. And there are three ways to represent ratios. One is with the word 2, so 2 to 3. You could also do that with a colon, 2 to 3, or with a fraction bar, 2 to 3. Either way, you would say them all 2 to 3. Okay, and also a little saying that I always do with this, so write this down. Ratio, make a bow. Okay, and I'm going to put a little bow. So ratio, make a bow. So what you're going to do is when you're looking at a problem, and we're going to look at this first, is you're going to find the word to, T-O, and you're going to circle it. And then you're going to put a bow around what's on the two sides of the word to. So bananas, peaches. This just helps you identify what two things you're comparing. And the other important thing is on a ratio, you have to compare them in the order that it asks. So you cannot mix the numbers up. So the bow helps you to identify what you're comparing and then make sure you're putting it in the right order. So let's look here. We have bananas, 4. So I'm going to put a 4 underneath that. Peaches, 3. A 3 underneath that. And that's it. My ratio is 4 to 3. Now, if I could reduce it, I could. But in this case, it's already simplest form. So I can either write this as 4 to 3, 4 dot dot 3, or 4 to 3. Any of those would be correct. Okay, so let's try the next one. Apples to pineapples. Ratio, make a bow. Circle 2. I'm comparing apples and pineapples. Okay, apples, 6. Pineapples, 2. Now in this case, I can reduce this because I know that 6 and 2 are both even. So I'm going to choose to write it in the fraction form. Remember, it's not actually a fraction, it just looks like one. So 6 over 2. Now, I know with fractions you might think, well, usually the numerator is smaller, right? But this isn't a fraction, it's a ratio. So you put it in the exact order that it says here. 6 was first, so 6 goes on top. Now I'm going to divide, well, both of those are divisible by 2. So 2 over 2, 6 divided by 2 is 3. 2 divided by 2 is 1. So my ratio of apples to pineapples is 3 to 1. Okay, let's try the next one. Go ahead and do the last two on your own. Okay, mango, 5. Total fruit, well, that means I need to add them all. So, let's see. This would be 10, 13, 14, 15, 16, 17, 18, 19, 20. So the total is 20, so this would be 20. Now I'm going to write it in the fraction form, even though it's not a fraction. So 5 over 20, again, the 5 went on top because it was first. And I can reduce that by 5 over 5. That would be 1, and that would be 4. So my ratio, again, I don't say 1/4. I need to say it in this form, 1 to 4. All right, and the last one, total fruit to apples. Well, my total is 20, and the apples was 6. again, 20 over 6. And I know I can divide that because they're both even. Let's see if anything besides 2. Can't think of anything. So 2 over 2, that would be 10. And 6 divided by 2 is 3. So 10 to 3. Okay? And I'm going to go ahead and circle these just so they stand out a little more. All right, so now we're going to look at this in word problem format. So, a bouquet, like a collection of flowers, a bouquet has 24 daisies and the rest roses. If there are 56 flowers in all, what is the ratio of roses to daisies? All right, so first of all, ratio, make a bow. I find the word to in my question, and it's wanting me to compare roses and daisies. One strategy you can use for this, I call part total. Well, when you're talking about a ratio, you're always going to have some parts and a total. So part, total. So one part would be roses, one part would be daisies, and then we'd have total, which would mean both combined. So it told me right here that I have 24 daisies. I'm going to put a D for daisies. The rest roses, well, I don't know how many rest is, so I'm going to wait there. And then it says 56 flowers in all, so 56 would be my total flowers, daisies, and so this would be roses. Okay, so now I need to figure out, well, what is my other part? Well, if you're missing a part, if you have one part and a total, that means you subtract those to find the other part. So 56 minus 24, that's 2, and 5 minus 2 is 3. So that means I have 32 roses. Now I can actually make my ratio. So a common problem that I see is that students try to just pick the two numbers in the problem and put them in a ratio and reduce it and say that that's their answer. But in this case, it's given me the number 56, which is not either one of the things it's asking me for. So I can't use the number 56. I only need to use that to find the other part. Okay, so roses. Well, now which one of these? Okay, roses was 32. So 32. And I like to put it right underneath the bow so I don't accidentally get confused. And then daisies was 24. Okay, so 32 to 24. Now I want to reduce that and make it in simplest form. So let's see, what could I reduce this by? I know that it's even, so 2 would work. 4 goes into both, but I can think of a better one. 8 over 8. 32 divided by 8 is 4. 24 divided by 8 is 3. So now I'm going to write this into a sentence answer. And since the ratio is 4 to 3, I would say, write this with me, for every 4 roses, there are 3 daisies. So that's how you would explain the ratio. For every 4 of these, you have 3 of these. Okay, so let's use this same concept and apply it to this problem. Go ahead and read the problem, figure out what your part total is, and make your ratio, reduce it. Okay, now that you've had a chance to try it, let's look. The Princeton football team won 3 games for every 2 losses. What is the ratio of wins to games played? So ratio, make a bow. There's the word to, and it's comparing wins and games played. In other words, the total games. So I'm going to do part total, part total. I know that they won 3, so 3 wins. I know that they had 2 losses. For every 3 wins, there were 2 losses. And my total I don't have, but if I have both parts, I just add them to find the total. So 3 plus 2, that would be out of 5 total games. Okay, So now I can actually make my ratio. Wins is 3. Games played would be total, so that would be 5. And again, making sure you put it in the right order. I like to put it right underneath the bow to make sure I put it. Okay, so good. So 3 to 5. So now I would reduce if I needed to, but I don't, okay? And I'll show you it right here. That's where that 5 came from. I just added the 2 parts. Okay, now I just need to put my sentence. So how could we say this? For every 3 wins, there were 5 games played. All right, last problem. Miss Charles is making lemonade. For every 1 part lemon juice, the recipe calls for 3 parts water. Make a table comparing the amount of lemon juice and water needed to make 2 times, 3 times, and 4 times the recipe. So equivalent ratios is really just like equivalent fractions. Because you can write a ratio in the form of a fraction, you can think of it as, well, what do I do for equivalent fractions? Well, if it says 2 times, this just means that I'm going to do times 2 to both of these. Well, 1 times 2 is 2, and 3 times 2 is 6. So for every 2 cups of lemon juice, you would need 6 cups of water. Okay? And then if I went 3 times the recipe, from here to here, I would do times 3. So 1 times 3 would be 3. 3 times 3 would be 9. So for every 3 cups of lemon juice, I would need 9 cups of water. And 4 times the recipe just means start with what you originally had and do times 4. 1 times 4 is 4. 3 times 4 is 12. So for every 4 cups of lemon juice, you would need 12 cups of water. So really, it's just like equivalent fractions. Whatever you do to one number, you have to do to the other to make it, first of all, multiplicative, multiplying. You could also divide, like if I started with this, I could divide them both by 4 and get an equivalent ratio. But you just need to make sure you do the same thing to one number as you do to the other so that they're equivalent. Remember, you can't add or subtract something. Like I can't add 1 and make it 2 to 4. That would not be equivalent. Okay, you have to do multiplicative, meaning multiplying them both by the same number or dividing them both by the same number to get an equivalent ratio. All right, guys, that's ratios. Ratio, make a bow. See you next time.